Hello and welcome everyone to presentation on Java RMI. Uh, this is Parikshit Kulkarni and we have one more presentation, Karthik. Today presenting remote method invocation on the topic. So let's begin. What is RMI? RMI is basically remote method invocation of Java, similar to RPC, which is remote procedure call. So RMI is the logical extension of Java's write once and run everywhere model. So what is write once and run everywhere model? Basically, let's consider a Java class, a Java file, a .java file. You can compile the .java file using Java C compiler, using the Java virtual machine, and it compiles the file to .class, and the .class file can be used to run on any platform such as Windows or Linux. So basically we are taking the concept of write once and run everywhere of Java and extending it to a distributed network using RMI. A language-centric model, Java's portability and safety to distributed world, Java as the interface definition and implementation language. So taking Java as the interface language, and this model is language centric compared to RPC, which is a generic model. The RMI is mainly concentrated to Java language, and it has got Java's portability. Like I said, it class file can be easily ported to any platform such as Windows or Linux. And we also get the security and the safety features of Java and apply it to the distributed world. And RMI also supports existing and legacy systems such as JNI and JDBC. So what are the advantages of RMI? It is an extension of RPC model and to the object-oriented world. So the traditional RPC are language neutral. So basically we are comparing RPC to RMI. When we compare both of the models, we can say that RPC is a generality or a generic model, and RMI is a specific model, and RPC is a generic model. So the objects can be passed as arguments and returned as results. Complex objects can be passed without any extra client code, as opposed to RPC, where client code is required to decompose complex codes objects into primitive data types and ship them and reassemble them on the server side. So we get the mobile behavior. RMI can move class implementations from client to server and server to client. So there is automatic class loading. So as compared to RPC, it is a model where the objects such as primitive objects can be passed from server to client or client to server, whereas in RMI we can pass complex objects such as Java Bean object or any other kind of class or objects, or even methods can be invocated using the RMI. So moving on to other advantages of RMI, the design pattern of RMI is basically similar to the design pattern of Java, and it implements the safety and security of Java, so it is more secure compared to RPC. And since it implements Java's model, and it is very simple to understand, and the simplicity is more compared to RPC. It connects to existing system, as I said earlier, like JDBC and JMI, and also there is portability based on Java. We also have the Java's memory management system called as garbage collection. So what garbage collection does is it marks the inactive objects and sweeps them. So that facility is brought to RMI and implemented in a distributed network. And there is parallel computing too. Part of RMI has become part of the Java development kit version 1.1. So you don't need to install any install or add any extra components as such. It comes with a JDK. You install the JDK and you can easily implement the RMI with no need of any extra additional software installation. So moving on, RMI extends the basic Java object model beyond a single virtual memory address space. So, like I said, the Java has address space such as heap and heap memory and stack memory, where dynamic objects are stored, static objects are stored. Basically, the memory space is located in a single machine. But in the case of RMI, it extends the functionality to a distributed network where there is something called as virtual memory, which is located in a network uh, through a network of a server or any uh, client machine or any computer which is distributed over a network. So so that a computer from one place to place can access a system from from a destination, from a different destination, using the concept called as virtual memory address space. So it allows remote method invocations between different virtual memory space connected by a network. Objects can be passed as arguments and returned as results. So as compared to RPC, we can pass objects easily as arguments in Java RMI. It uses object serialization technique for marshalling and unmarshalling. So uh, when the client sends any object to the server, the object is serialized and it is sent to the destination, and there is marshalling in the client side and unmarshalling of the object on the server side. Any Java object can be passed during invocation, including primitive data types, core classes, user-defined classes, and Java beans. Allows a clean system design since it is based on Java. It allows a clean and simple system design. Natural progression of RPC model to the object-oriented world. As I said, it is just an extension of RPC model, but it is more specific to Java, and we also get the implementation. We are also introduced to the object-oriented world. Remote calls are transparent to the programmer. So as I said, RMI is similar to it since it implements Java. Java has its own platform called as Java Virtual Machines, such as other platforms such as Windows platform and Linux platform. So Java has its own platform called as Java Virtual Machine, which can be installed in any platforms, OS platforms such as Windows and Linux and Mac OS. Um, so basically, the implementations, the Local implementation of objects and functions are similar here in the Java RMI. So any user who's writing a function of RMI using RMI, it would look similarly as if he is writing a local function, since there is not much difference between the both implementations. Syntax of remote method invocation is same as local invocations. As I said, there is not much difference in the syntax. RMI operates only in Java domain. Developers work with a single object model instead of working with multiple models. So in case of RPC, it's a generic model, whereas it can be implemented over different across different domains. So a developer's expertise, a developers different developers can have different expertise. So it becomes difficult for another developer to work on the same application as such. So this specific domain model allows the developers to concentrate on a single domain and work together easily. Simplifies the design. Burden of memory management is removed. As I said, there is automatic garbage collection, and it is provided in a distributed environment, extended to the distributed network. So different operating systems located over a distributed network can implement the functionality of Java's Java garbage collection easily. Executable code can be dynamically distributed on demand. No need for pre-installing code on client machines. So as I said, once you install JVM or a Java development kit which comes with JVM, you can write the code once in any platform and run it everywhere. Secure nature of Java is exploited. RMI clients interact with remote objects via their published interfaces. Unlike local Java calls, RMI passes local objects in the parameters by copy instead of reference. So the local objects in case of Java are passed by reference, but here in the case of RMI, the whole copy is made of an object, local object, and the copy of the object is passed across the network to the server machine. Remote objects are passed by reference. So here remote objects are passed by reference. RMI provides a very primitive non-persistent naming service, class loaders, and error handling via remote exceptions. So RMI takes on the feature of exception handling of Java, and it implements a different class of classes and interfaces of exceptions called as remote exceptions, which can be used for handling these different kinds of exceptions which occur in RMI code implementation. Excuse me. So basically, as we see in the figure here, there is a client machine which may have a different operating system, and a server machine which can have a similar or a different operating system. The client machine has something called as stub, and a server machine has something called as skeleton. And the server implements RMI registry, and this client or server are connected in a distributed network. So here's the process of RMI. So we define a remote interface, and then we implement the interface, and then we use the Java compiler to compile the interface. And then, as you can see here, a stub is where the Java's local object copies are made and remote method references are stored. And it is passed across this network to the skeleton where a copy of the object is present. So we run the stub compiler using RMI compiler, and we start the RMI registry. So RMI registry is something where it has its own stub, and the remote objects are placed into the registry, which is referred or invoked. Objects and methods are invoked by the client machine. So we start the RMI registry and we start the server object, and then we register the remote objects and remote methods into the registry, and then the client machine is implemented, and client side code is implemented and compiled. So once we start the client machine, after compiling, the client machine requests the objects, and it or the remote method invocation occurs on the server side, and the server gets the request from the client machine, and the virtual memory address space which contains the addresses of the requested objects and methods are passed on to the client machine, and it accesses the required methods and functionalities from the server machine as if it is accessing from a local machine. So thus the whole process of remote method invocation. So the next topics will be covered by Karthik.
Hey guys, my name is Karthik, and I'm going to teach you how to compile and write a RMI application. In order to write a RMI application, first thing is we should write an interface. This interface is the contact between client and server, which declares all the business methods that can be invoked by a client. If this interface has to be a remote object, then we need to extend this interface with remote interface. To work with RMI, we need to import java.rmi.star and import java rmi.server. This remote interface is available in the RMI package. And another thing is, during the method calls, there could be a network problems due to which we end up getting remote exceptions. So all methods must use throws remote exception. This is what gets into an interface. Next step is to write the implementation of a class. That is, implement the above interface, implement the methods of the interface, extends from unicast remote object class. This class helps in exporting objects. It also identifies the type of server, that is, it is unicast type of server, which means I cannot replicate the objects. Next step is to write a program which is going to create an instance of this class. Let's call it a server program. Server program will create an instance of the implementation class. Now we need to place this remote object onto the registry. Now we need to place this remote object into the registry. So in order to place the remote object onto the registry, we make use of the concept called binding and rebinding. Now the question is, what is the difference between bind and rebind? When we use the bind method to place the object with the bind name, you cannot later replace this bind name with the other remote object. We get the bound exception if we try to do so. But in the case of rebind, specifying the bind name and the remote object, Later in time, if we want you can change the remote object specified for this bind name with an other remote object. So it's just a replacement. They are independent on each other. Wherever the server program is running, wherever I'm gonna run this particular program in the same machine with the default port here is 1099. RMI registry is running because I'm gonna place this onto RMI registry. This is the remote method call to the RMI registry. Next thing is to write the client program. First thing is it has to fetch the remote object to invoke a function. Then you invoke the method on the remote object. Now the question is, how do I compile all this? To compile these programs, first compile the interface using the function Java interface. Then compile the implementation class. Then we compile the server program, and finally we compile the client program. Now, where do we get the stub and skeleton? To derive it in stub and skeleton class, you make use of the command called RMIC, that is Remote Method Invocation Compiler. The next final slide is how to run the program. To run the RMI application, first thing is that we need to do is set the class path where the stub class can be found. When we set a class path, it must be an absolute class path, not a relative class path, and start the registry. And in order to do that, we need to enter start RMI registry. When we do that, it opens the command prompt window in that the registry is getting executed. Next step is to run your server program, which has the main function in it. So this is how you run the RMI application. Thank you for watching the video.